setup because all the setups are different from the last time I've taken a 151 lecture, so everything's a little bit chaotic. But I think we're good to go. So as you can see, I'm not Jake. I am, so if you were in the last lecture, the Monday lecture, you would have probably seen my face a little bit. But hello everyone, I'm Tammy, and I'm one of the course admins of the course alongside 3 other really amazing course admins. And I'm currently studying like PhD, like doing research in something called computational machine ethics. And so Jake has been very kind and allowed me to take this lecture today because I love doing things like this. And then he's just like, yeah, you can take a lecture today. So I'm taking the lecture today. This is also one of my favorite topics. Also one of, in my opinion, a very confusing topic. So hopefully we're good to go. I don't know. We'll see. I'm quite nervous about this, so just bear with me. And if you have any questions, please feel free to ask anytime. This straw is really annoying me. Yeah, if you have any questions, just don't hesitate to ask anytime. Put your hand up, and if I'm not seeing you, just, shout, like, let me know. Or you can put your questions in the chat. I have the chat open, although I'm not very good at multitasking, so I might not be able to see. Oh, some people say hi to me online. Hello. Anyways, so to start off, today's lecture slides, as you can see, is a bit different. It's my style, which is very pink. I have a lot of pink things. Anyways, moving on. So pointers is the main topic today. We're starting something totally new, and this is a very important topic because it's going to be the basis of what you will learn in the next couple of weeks after Flex Week. And we try and introduce it before Flex Week because it can be quite difficult to get your head around. So this is like an opportunity for you to get a taste of what it's about, and then go home and think about it over the week as you're cramming your assignment ones. And yeah, and let's learn about together. But before we do that, just a few announcements. So week 6, I'm gonna do it in reverse order, right to left. Week 6 is flexibility week, so that's next week, which means there's no lectures, there's no cheat labs. It's a break for everyone. I guess it's a time for you to catch up on all the lectures that you have missed out on if you're behind. And then, however, we've got help sessions and revision sessions both running next week. So even though there's no classes, we've got in-person and online help sessions and revision sessions. Actually, quite a lot of help sessions. So if we go onto the course website, you can see week 6, we've got quite a lot of help sessions, and we know that everyone's probably stressing about the assignment, or a lot of us are stressing about the assignment if you're coming to the help sessions in week 6. So what we've done is label them as like stage-specific help sessions, as in these particular sessions are for particular stages, just to try and help out the people who might still be starting out a little bit more. And then and yeah, so that's the help sessions. What was it? Oh, revision sessions. It's not on the forum yet, but after the lecture, it will be. I will send a link on the forum where you can sign up for 2 revision sessions next week if you're interested in catching up on some of the topics that you might feel like you're behind on, or if you have any questions or just want tutor to go over something with you. So those are helpful. Keep in mind that help sessions and revision sessions are not the same thing. It can be quite confusing. But yeah, you can sign up to revision sessions and you can just rock up to a help session. Okay, so that's all the announcements. Are there any questions, admin-y kind of questions at the moment? Coolios. I'm just gonna mute my phone because I forgot to do that. Okay. So as usual, the live lecture code is where it is. It might look a little different this week because I've split up Jake's code into a different folder to my code that I will be working with. But it should be quite intuitive to navigate around. Okay, so the whole purpose of today, as I've said, is to introduce everyone to pointers. And before we do that, I need to talk a little bit about memory, okay? So memory, we're talking about the computer memory. So I actually don't remember how much memory my computer has. But everyone, when you buy your computer, you will look at the specs and you'll be like, oh, how much RAM or how much memory? Some people might use the word RAM, some people might use the word memory. They mean the same thing in this scenario. So how much memory do I need in my computer? And that's the working space for your computer. For example, when you're running your programs in this course, or when you're opening any kind of applications and working on your laptop, all of the data related to those things or those programs are stored in the computer memory. And so how it's actually stored, it gets complicated, but you can visualize it as like there's a grid or sort of a grid, and there's values inside the grid and there's specific addresses, okay? So what I mean by addresses is just like how everyone lives somewhere. We all have a home. So we all have a home address, which takes us to our home. So within the computer memory, there's a home address for each particular data that we store inside the memory. And so for example, a very familiar piece of data is like an integer variable, like value stored in an int. That will be living inside the computer memory somewhere with a particular address, okay? So with us, our home addresses, we have things like number 8 Barangaroo Avenue or something like that. That's not my home address. Anyways, that's not my home address. I just picked a random address. But in the computer memory, they're not referred to it like that. They're referred to it with hexadecimal values. So you will see in a bit, there's like some fake addresses here, and I'll probably print out some during the lecture to show you some real addresses. They start with OX something 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 kind of vibe. But yeah, they look a bit funny. But anyways, each slot, so each piece of data or each slot where you can store data will have its unique memory address so that you can kind of navigate to it in a way when the computer's running programs and so on. So that's like the general introduction of that memory. The main takeaway here is what is a memory address. Okay, so before I actually explain what pointers are, can I get a show of hands? And online, can you just type 1 in the chat? If you have heard of pointers before. You don't have to know about it, you just heard of it before. Okay. Other than from Jake. Like heard of it outside of Jake mentioning it. Okay, a little bit. Okay, nice. One, okay. Has anyone heard about the, I guess it's not rumors, it's like, has anyone heard about like, people say online probably as well, like pointers are so hard, they're like everyone struggles with pointers when they start programming and so on? No? That's great, because we'll hopefully make it less hard today for everyone, and you can go online and tell people pointers aren't hard, that you know. But it is hard, it is tricky to get your head around when you first start. So please be patient with yourself and ask me questions. So I've got a toilet sign here. The reason why I've got a toilet sign is because, okay, this is not an analogy that you want to take to the extreme. I just want to kind of give everyone the vibes of what pointer is getting at. So when you're in a shopping center or you're at the airport or anywhere in a public space, you will see toilet signs around. But the toilet isn't where the toilet sign is, right? The toilet is where the toilet sign is pointing at, and it will lead you to where the bathroom, where the toilets are. So it's kind of like there's a sign that you go to, and then that will guide you to where the bathrooms are. And pointers are a bit like that, okay? The other example is, I have a kid here pointing at a car. So I don't know if anyone's played Spotto before, like where you see like yellow cars on the road. But yeah, when a child sees, or when someone sees a yellow car on the road, they point to it. They're not the car, but they tell you where the car is, right? So the general idea here, if we take it into the context of pointers, is pointers are variables that take us to another variable, okay? That lead us or that point us to another variable. You might wonder what's the point of that. Hopefully we'll answer that question later in maybe 40 minutes. Alright, so the technical definition here I have on the slide is pointer is a variable that stores the memory address of another variable, because we know the memory address of a variable is unique to where it lives. So if it stores the memory address, then it's basically telling us where it is and we can go to it kind of thing. So the variable stores the memory address, and a lot of people will talk about that like casually in conversations as, oh, we have a variable that points to another variable. It leads us to another variable, kind of that. So the benefit of that is it actually gives us the power to modify things at the source variable or source data in the memory, which might not make sense at the moment, but it will make sense when I do an example with functions. Okay, so to use a pointer, so a pointer variable, since it is still a variable, we would always want to declare variables. So the syntax looks a bit like this. The blue is the type, okay? So you specify the type of pointer, which what that means is since a pointer variable is a variable that stores the memory address of another variable, you specify the type of variable that it will lead you to, it will point you to. So in this case, for example, I can have an integer pointer variable, which is what I've got as an example here, where this just says int, I want to declare an int pointer variable with the variable name num underscore ptr. Ptr is the short for pointer for me. So I just wrote that as the variable name. So that's how you would declare an integer pointer. And all that means there is this variable can store the address of an integer variable. So it can lead us to another integer variable. Does that make sense? I have a question down there. Yeah. Really good question. The variable name is the name of the pointer. Is the name of the pointer variable, as opposed to the thing that it's pointing to. The thing that it's pointing to may have another name. It has a different name, which hopefully is on the next slide. Any other questions before I go to the next thing? Okay, hopefully it makes sense so far. Okay, so what I have here is a part of the memory, specifically the stack in the memory. We haven't really spoken about different parts of the memory, but this is a portion of the memory called the stack, and which is the bit that we've been fiddling with when we're writing our programs so far in this course. So what I have is, I said like the memory is, you can visualize it as a grid. So I've got kind of a grid here, or like a like 4 boxes to represent a portion of the memory. And then what's on the right hand side is fake. Okay, this is not real. This is fake memory addresses. Okay, just to tell you, hey, this is what memory addresses could look like with the OX in the front. These are hexadecimal values. So that OXFF4C is referring to this particular location in the memory, and then OXFF4A is referring to this particular location in the memory, and so on. Okay, so that's just what's happening here. And I have this blank kind of uninitialized, I guess, portion of the memory because I want to go through some code, a little bit of code. So how pointers work is, or how pointers can work is, you can declare and initialize an integer variable first. We are all familiar with this now, where somewhere in your code, if you have int number equal to 8, the computer will go, okay, I'm going to declare a variable called number, and I'm going to store the value of 8 somewhere in memory. And then it will pick some location, the appropriate location to store that. And so once we've done that, okay, what we can do with the pointer now is, like I said, pointer leads us to another variable. And so we're declaring a pointer to make it lead to this particular number variable that we've just declared. Okay, so in this case, we're declaring an int asterisk, so int pointer, number pointer variable, and then we're making it equal to, okay, this is a new notation here. So I introduced the asterisk, int asterisk notation before, about that saying that's the int pointer type. Now we've got the new notation here with the ampersand, which means the address of, okay, the address of. So in a full sentence, what this line of code means is, hey, let's declare an int pointer variable called number underscore pointer. And I want the value in that pointer variable to be equal to the address of where our number variable lives. Okay, so I've reflected that on the diagram on the right, where if we do the second line here, we will now have, so as opposed to the previous slide, we will now have a new variable somewhere else in memory that is going to store the address of 0xFF40, which is where the number 8, the integer 8 lives. Okay, and I've kind of used an arrow to indicate that that pointer points to the variable that stores the value of 8. Does that make sense so far? Okay, so this is where this ampersand might answer some of your questions today about scanf. So I think in the either first or second lecture I think, we introduced scanf, and then we were just like, oh, you can use scanf. You need to use ampersand for your scanfs, and just assume, like, always use ampersand for your scanf. But why? This is why. Okay, we're actually working with pointers without knowing that we're working with pointers. When you're doing an ampersand in your scanf, you're saying the address of that variable, where that variable lives. Okay. So given these two lines of code, what's actually true in this case, like I've repeated before, is number is the value of 8, and number pointer has the value of 0xFF40, which is the address of where number variable is. And, okay, on top of that, another new notation, this asterisk thing here. So I introduced the asterisk before, but now I've got asterisk again. You might start hating asterisks after this lecture. But we have another asterisk here, and this is different, okay? Can everyone see my mouse when I hover around things? Okay, thank you. So this asterisk has a different meaning to the asterisk before, which means the type, int pointer type, right? Because this asterisk is on by itself. The other asterisk was like right after a variable type. This asterisk is by itself, and when you see an asterisk by itself in code in C, what that means is something called dereferencing. And what dereferencing is if I put this into a sentence, it's follow the number pointer to where it's pointing to. Okay, that's what the asterisk is saying. So whenever you have an asterisk in front of a pointer without the type, then it's saying, hey, can you follow the pointer to the variable that it's pointing to and access the value inside that? So in this particular case, if we follow the number pointer to where it's pointing to, it's pointing at the variable that contains the number 8. So that's why I've done this equal here, because this statement is true here. So the main takeaway from this slide is these 3 components, which is basically all you need to work with pointers. Actually, mostly. There's a bit more. Mostly what you need to work with pointers. And you just got to remember what the meaning of each ones are. And you might forget because, you know, we're still learning about it, but hopefully in the next few weeks you'll be like, oh, I know exactly what this is.
You mentioned that asterisk is the type of the pointer?
Okay, so there's two asterisks here. So if I go back, this one, when I have the asterisk following the variable type, so in this case it's int asterisk, it could be like char asterisk, or it could be double asterisk, let's say. This is the variable type. So in this particular case, this variable is a integer pointer type, meaning it can store the memory address of another integer variable. So if I have a double pointer type, then the variable can store the memory address of another double variable. Does that make sense? So that's the first thing. The second thing is the other asterisk, which appears independent of any types. It usually appears right before any pointer variables, but without the int or the double or anything in front. So what this asterisk means is what we call dereferencing the pointer. Follow the number pointer to where it's pointing to and access the value inside the variable that it's pointing to. Okay, hopefully that makes sense. We have another question? Yes.
You have to declare integer point variable before you access like that?
Do you have to declare your integer pointer variable? Do you mean the integer variable or the integer pointer variable?
I mean, do you have to have the line int asterisk number pointer equal something?
Before you do this? Yeah, You do. That's a really good question because it's not quite clear here. So indeed, you need to have done this particular line here, which is declaring the pointer, right? Before you can do something like this, where mouse is hovering. Just like any other variables, we got to declare it before we use it in any way. Any other questions before I move on? Yeah. Why is hexadecimal used? I'm actually not sure. That's a really good question. Do you guys know? Yes, Tim. There you go. It stores more information, so you have to read less digits. I don't really have. Do you have more details? Like, I kind of want to. I'm gonna give you this. Do a little thing.
So we use hex because hexadecimal is base 16, and it just so happens that bytes store 8 bits. So one hexadecimal digit represents 2 bytes. Whereas if we use base 10, it'll be one digit represents like 1.5 bytes, which is a bit hard, which is less nice.
Okay, thank you so much, Tim. Hopefully that answers your question. If you want to know more, I can find out for you, or Google is your best friend, or ChatGPT. Okay, so, all right, coming back. Any other questions before I move on to the next slide? This slide is quite dense, so that's why I'm staying on it for a bit. Okay. Cool, so I said 3 components, declare, so the 3 components are declaring the variable, then we have something that can access the address of a variable, and then we have something called dereferencing. Alright, so this is a repetition. I'm just putting it on the slide because it's a nice TLDR for when you look back on it, but it's the same thing as what I just covered. Yes?
Find your customized slides?
Good question. It's on the exact same spot as where Jake's slides are.
It wasn't.
I changed the access maybe like 30 minutes before the lecture. So if you checked before 30 minutes before the lecture, you wouldn't have seen it. Can you see it now? Give me 2 seconds.
Use the second one for Wednesday.
Oh, jokes. Thank you. It was there the last time I checked. I must have done something weird. I will fix that up right after the lecture. I guess that means no spoilers for everyone. Oh, you know what? I know why. We have an automated script that replaced my slides that I uploaded. It's fine. I will fix it up after the lecture, so I promise you'll get my slides. And it will be in the same place as where Jake's slides are. Alright, so with all that in mind, I'm going to do a little coding thing with exactly what we just covered, just to show you how it works in the program. So I'm going to declare and initialize an integer variable. And I'm going to make a num pointer, right? So this is saying this is an integer pointer, and I want it to have the variable name of this. And here I want to assign it with the value of where our num integer variable lives. So that's going to give me the address of num. Okay? So now I just need to print everything out to show you that I haven't been making things up today. So I can print out things in a few ways. I can print out the address that num pointer is pointing to. Is storing, actually. Let me call that. Okay, so to show you what an actual address looks like, because I've been using fake addresses in the slides. %p is something you may not have seen so far. it's the placeholder that we use to print out pointer addresses, okay? Memory addresses. So in this case, I'm printing out the memory address of that num pointer is storing, which is actually where the num integer variable lives inside the memory. If I compile this, so we can see an actual hexadecimal memory address. Very complicated and long. It will be different if I run it again, as you can see, because then now the program is running again, the operating system is trying to figure out where to store the variable again. Yes?
So is it convention to name
That's a really good question. So the question for online is it convention to name a pointer with the underscore PTR? The answer is no. I've just done it this way. I can call it something else. I can't think of something. Nope. But I've just named it PTR for the sake of introducing pointers, so it's easier for us to distinguish between pointer variables and no pointer variables. But when I usually code, I don't do PTR either. You don't have to. Yeah. Yes.
if you put the asterisk in front of num pointer, would it print out 8?
Aha, let's try that. Uh-huh. Let's try that. So I'm gonna try and print out asterisk num pointer, right? Like, ooh, not the ampersand, asterisk, don't get it wrong. Which was what I said would take me from the pointer to where it's pointing to and access the value of the thing that it's pointing to. And let's see if that gives us 8. Because, there you go, 8. Because that is what the num variable had, right, inside the value inside it. All right, so the other thing, just to confuse everyone a little bit, the other thing you can do is you can also print out the address of the pointer variable itself, where the pointer variable lives. Percentage P ampersand num pointer. Okay. So all I've done here is used a notation that I covered before, the ampersand in front of the variable name, meaning, hey, get me the address of where this particular variable lives. Okay. Now, this is different from the other address I printed out, and they're different in the sense that one is printing out the address of num, the other one is printing out the address of num pointer. So if I use a diagram, the previous diagram I had, basically one, if I use this particular example on my right hand side, one is printing, the first address was printing out OXFF40, which is where the number pointer is pointing at, the variable that is pointing at. As the last one that I just added, the printf with the pointer, the new address, the second address is OXFF48 in this particular context, because it's talking about where the pointer variable lives inside the memory, as opposed to the address or that the pointer variable is pointing at. Yes?
So if you printed add num, would you just get the same thing as number pointer?
If I print the thing and num, let's give that a go. So if I print, so this is num pointer, and this one you wanted me to print out and num, right? Okay, let's give that a go. Yes, because they mean the same thing, exactly. Yes. Aha, so what's the point, right? Did anyone get that pun? Okay. Wasn't that funny? Anyways, we'll get there, I promise, in a bit. Because I need to show functions, like pointers and functions, and you'll be like, oh, some of you might have struggled with functions with the question of, oh, how do I return multiple values in functions? This will answer it. But if you don't know what I'm talking about, it's okay. We'll get to it. Okay, so where am I up to? Alright, so I haven't finished this pointers demo yet because I'm going a lot slower. Ooh,
I have another question.
yes.
Can you store arrays with pointers?
Can you store arrays with pointers? Now, the answer is actually arrays decay into pointers. So arrays, when you're referring to the array name, it actually gives you the address to the first element in the array. I will do a demo to show you that, which will make more sense. There's a lot coming through. But yes, so you can use arrays kind of like pointers. They're not exactly the same, but there's a bit more to this. Give me like 50 minutes. Okay, so what am I doing? Oh, I wanted to show you the complication of using pointers like this, okay? I find it really confusing. Pointer variables address. I've already done that. I'm gonna skip that one. Okay, I find it really confusing using pointers, and one of the reasons why that is the case is, so currently, my num, right, we printed it out before, but I'm just printing it out again to make it clear, is 8. So in theory, this should be 8. But if I do something like this, okay, what's going to be the value of num after? Yes, 24. And it's confusing to me, or might be confusing to you when you debug code with pointers, because we're not doing anything with num. We're changing something that is pointing at num. And if we don't see the code before where we're like int num pointer equals to ampersand num, and we just see this, we're just like, why did num change? Like, I don't know why num changed. I never did anything like num equals to blah. I find that really confusing. To add another layer of complication, if I make another pointer, okay, and I make it point, so when I do this, okay, have two pointers equal to each other, this is saying make num pointer 2 point to where num pointer is pointing at. So in this case, num pointer 2 will now point at the integer variable we had, okay? Because our num underscore pointer is currently pointing at that. So if I had something like this, and I went, hey, now let's change the thing that the value inside the variable that num pointer 2 is pointing at to 10, and I try and print f num again, it's unfortunately going to change again. Okay, and this time we've changed it by a different pointer again. And then to make it even more confusing, once a pointer points to, so num pointer was pointing at num, right? I could now decide, hey, I don't want num pointer to be printing at num anymore. I want it to print at this new variable I've made. Okay, and I can do that. So then if I try and print f num pointer with an asterisk in front, meaning, hey, go to the value that num pointer is pointing to, it's going to print out the 4 instead of the 8. Okay. Does anyone want me to draw a diagram for this, or are we Are we? Okay, hands up if you want me to draw a diagram to say what's happening here. Okay, let's go. I brought my iPad for a reason. Okay, let's give me a second. Okay, I have a teeny weeny screen, so we're gonna have to just work with what we got. Is it coming up? Yeah. Okay. So I'm not gonna draw the memory like what I have in the slides. Let's just all pretend that this blue background is inside the computer memory, okay? So I'm just gonna draw random boxes to represent different slots in the memory to store values, to try and simplify things a bit. Okay, so originally, if I start at the beginning, I did a int num equal to 8. What happened there was, oh, this is tiny anyways, is the computer will allocate a piece of memory that's going to allow us to store the value of 8 inside it, and that's for a num variable. So that's what happened on line 10. We have a slot in our computer memory that stores num8. Then what happens on this line is somewhere else in the memory, we're like, hey, can you give us a num pointer variable? So this particular box is going to be called num pointer. I hope my handwriting's not too bad. And we're saying, hey, can you make num pointer equal to the address of where num is? So let's say the address of num was, I'm just going to put it beside it, 0x88 something something, right? Then this will be what's stored in here. Okay. I like to use the arrow notation to show that. So it's like this pointer variable is pointing at this particular num. Does that make sense so far? Yes? Okay. Moving on. So that's the first two lines. And then so these are just printfs to print out the values, right? So numptr will print the address of what numptr is, and numptr will have its own address like 0x78 or something, let's say. I'm just making things up. Why is my... Okay, there we go. Okay, there we go. Okay. Yeah, so num pointer will have an address. So the one at the bottom is where num pointer lives. The one inside the box is storing the address that we want the variable to point to. Any questions about that? All right, so from here, okay, we printed out a few values. Let's go to the bit where I think started confusing everyone. So num is equal to 8. This is our current situation in our drawing. Then what I say is, hey, asterisk num pointer equal to 24. All I'm saying there is, hey, dereference num pointer, meaning, hey, can we follow num pointer to where it's pointing to, right, which is this variable, num, and I want to change the value inside it from 8 to 24. Yes?
By dereference, do you mean just a reference
By dereference, so it's a technical term for when we have something like this, where we have the asterisk in front of a pointer variable. And when we say dereferencing a pointer, we're saying follow the pointer to where it's pointing to and look at the thing inside the variable that's pointing to. Does that make sense? Any other questions? Okay, so where am I? Oh, line 29, sorry. So we dereferenced our num pointer, which means we followed our num pointer, so I've drawn it in red, to where it's pointing to, which is this variable, and we've updated the value to 24. Are we all good with this? Or not good? Okay, I see thumbs up, so I'm going to move on. Let me know if questions. So we printed out num this time, and it said num is 24, right? Because we updated num via this pointer using line 29. So then on line 32, I've made things more confusing by saying, hey, let me use green. Oh no, green's gonna look, okay, I'm gonna use orange. On line 32, I've said, hey, let's declare another pointer, okay? I'm gonna call this pointer num pointer 2. That's what it says in the code. And I want it to equal to num pointer. I see a hand, give me a second. Which means, hey, because these two, like the two things on either side of the equal sign are both pointers, we're saying make num2 pointer, so this particular line, let me highlight it, equal to where num pointer is pointing to. So num pointer is currently pointing at this variable, right? So I'm going to make num2 also point at that variable, because that's what it's saying. Make them store the same address. We have a question at the back.
So, because there's no ampersand, I'm not really looking at ampersand at all. But my guess is that sort of ampersand in that line, 4.1, then would make a pointer to point 1. But if there's no ampersand, you're making a pointer to point what pointer 1 is pointing to.
Exactly. You're spot on. It sounds very confusing, but you're spot on. So the ampersand, in short, is talking about the address of the variable. So when you have an ampersand in front of the variable, it's saying go to where that variable lives. So go to where num pointer lives. So if I had an ampersand in front, so I like the original code doesn't, but let's say if I had an ampersand in front, instead of num2, so the orange arrow pointing to where it is right now, it will instead point here, okay, this way, which is actually out of the scope of this course, because this is a pointer pointing at another pointer, okay? It's something called a double pointer, and we don't go into details in this course because that gets confusing. That can get quite complicated. So, but yes, you can do that. Okay. So this is the original code. And that's what's happened. This line 32 gives us the orange bit. Does that make sense? Okay, I'm going to keep going. So then when I say now, hey, asterisk num pointer 2 equal to 10, again, when I have the asterisk in front without like a type in front of it, that's dereferencing once again, like before. But this time it's num pointer 2. So we're saying, hey, let's dereference num pointer 2, which also means follow num pointer 2 to where it's pointing to and change that value to 10. Where is num pointer 2 pointing to in my diagram? Yes, which is? Thank you. Okay, so then we'll update this. Where am I? To 10. Right? That's what that line did. And so when we printed out num, it printed out 10. Because num variable now has the value of 10. It got changed without it knowing itself, kind of vibe. Okay, why did I make it so confusing for you guys? Anyways, here, line 37. Now what I do is I say, hey, let's declare another integer variable called num2. So I did this, and I'm drawing it. And I want it to have the value of 4. And then now what I'm saying on this line, actually, whoever answers this question gets a Malteser from Tim. What does this line do on my diagram? Someone, yes?
It assigns the address of num2.
So that means it assigns the address of num2 to num pointer? Yes, num pointer. So what that means is, let's say if this address was 0x76, then we're basically updating what's in num pointer, which is the same as in my diagram, my arrow is changing. So I'm making that arrow point to the new thing. Yes. Can you throw the Matisse off? Alright, so that's what's happening. And so when we print out now, the asterisk before, with the asterisk before the pointer name, like this, we're dereferencing number pointer again. And this time, number pointer is now pointing at our num2, right? So when we dereference it, it has the value of 4. How are we feeling?
Can I just add something?
Yes.
Why do we need this, and why can't we just simply say this number this and then directly mention it instead of making it so confusing and running around in circles?
So why do we need this particular example? We don't. I'm just making it to show you how complicated pointers can get. But why do we need pointers? I briefly mentioned it. It's because when we are trying to, like, you may have encounter situations when you're in a function and you want to return multiple values, and pointers will resolve that. I'll give an example of how pointers resolves that, but pointers will resolve the issue of if you had it in assignment 1, for example, where you wanted to return multiple values as well. But I need to give you the full story. In a bit, I promise. Yes.
So does the asterisk simplify address, or does it specify like what is the asterisk actually?
Yep, so the asterisk is saying go to the address that this pointer variable is assigned and find out what it is in that variable. So we've got a pointer variable. It's pointing at some other integer variable, let's say, right? If we put an asterisk in front of our pointer variable, we're saying go to the address that this pointer variable is storing, right? Which is this particular integer variable here, and look at the value inside it, or access the value inside it, or change the value inside it, depending on whether you're putting it on the one side or the other side of the equal.
Access is what it's pointing to.
Yeah. I'm so sorry. This will take a few times to understand. Bree, do you mind doing a poll in the chat? Everyone, you can go on the poll in the online. I just want to kind of gauge in person as well as online how we're feeling about pointers, what I've explained. Maybe like, oh, getting there, not good. Explain again, or like, we're good. I'm pro at it now, kind of vibe. Thank you so much. Okay, while that's happening, let's take a break. If you have questions and you want to ask, feel free to come up as well. And I can answer your questions here. Let's quiet it down. All right. I'm so sorry, everyone online. I keep forgetting to repeat the question. Hopefully I will remember for the next hour. Okay. I tried covering up the answers, but I just realized everyone has access to the slides anyways. But it's okay, you know, A for effort. Okay, so little quiz. This is on a trust basis that you're not checking the answers on the slide. But some of these code might not work. Some of them might work, okay? And my question is, will they work? And I want a show of hands and 1 for yes and 0 for no in the chats online for each one of them. So number 1, the first one, if we have an integer variable and an integer pointer, right? Can I do number 1 where I make the number pointer equal to the number like that? Hands up for yes, we can. Hands up for no, we can't. Okay. Okay, no. Okay, we've got some no's in the chat as well. Zeros in the chat. Thank you. Exactly. Woo! No. Exactly. Now one thing I think I was explaining to another student in the break, and I think that that's something I think might clarify for some of you, is to have a look at the type of the two variables. Okay? So, like on either side of the equal sign. So in the first one, the type on the left-hand side, on the first one, the type on the left-hand side is an integer pointer, whereas the type on the right-hand side is an integer number. Okay? So we don't want to do that in this case. Okay, second one. Hands up for yes, it will work. Or 1 in the chats. Hands up for no, it won't work. Okay, we've got a few no's. So this is where we look at the types of left-hand side and right-hand side to help us figure out again. Now, the left-hand side, we're saying dereference number pointer, which means go to where the variable number pointer is pointing to and access that value. Now, that value would be an integer in this case, right? As opposed to on the right-hand side, if we see an ampersand, we're always talking about the address of a variable. So one's talking about like an address, the other one's talking about an integer, like an actual integer value that we're storing. So not quite. Okay, it might still work, but okay, give it a go. But it doesn't quite make sense unless you're intentionally doing it, if that makes sense.
But it does work. So
All right, my question is wrong. I'll correct my question for the next time I use this set of questions. Did you try it?
I mean,
Nice. Okay. All right. Okay, the third one. What about the third one? Is it will this work in code? I guess the better question I should ask is whether it's valid and whether
well, you get a
it's appropriate. Yeah.
but it still works.
Yeah. Okay, so the third one, what do we think? Yes for it will work, no for it wouldn't work. Yes. No. Yes, it works, okay? Because I've shown that in the code as well. Now the last one, we already saw the answer, so I'm just gonna mention it. The last one is going to depend, okay? So if we look at the last one, we've got an asterisk number pointer equal to number. Now, remember the asterisk number pointer is saying, hey, follow the pointer to where it's pointing to. Now, there's a case where this will give us an issue, okay? And that specific case is if our number pointer is uninitialized, meaning we haven't made number pointer point at any variable. If we don't make number pointer point at variable, then there will be no value that we can access, which will cause an error in that case. Okay. Yes. What if it's defined later? It will cause error before you define it, because your code gets read from top to bottom and executed from top to bottom. So it's really important you do it beforehand. Yes. You don't need to add anything. Pointers are just an inbuilt thing in C. Yes. If you don't assign it before you use it, it will cause you an error. Does that answer the question? Yeah. Okay. Cool. Oh yeah, the other question I forgot to repeat for online is, but you can just use pointers without hash including any library. It's inbuilt into C. Oh, I'm forgetting things. All right, let's move on. All right, so finally we have a question. Yes. Last slide. Yeah. No, this pointer is uninitialized. Really good spot. The third one would still work because the third one we're assigning a value to it. Yes. So the question, so just to reiterate what's happening here, we have an integer pointer that's uninitialized here, okay, because we haven't made it equal to any address. So that's not going to affect how the third one works because the third one is actually now saying, hey, let's assign it with some address. Yes. The second line, yes, you can declare a pointer that you haven't initialized, and then you can assign the value later. Yes.
Can you explain number 4? Why is it dependent?
Okay, so if I draw a diagram, so I'm going to explain why number 4 is it depends. Okay. All right, so number 4 is it depends because there's two scenarios here. One is we have a number variable, right? Integer number variable. Oh, let me do. Oh. Yeah, there we go. We have an integer number variable. We also have a integer number pointer variable. Okay. If we take the code, the first line of code literally, then they're both uninitialized right now, right? They're both not initialized. Which means our number pointer, which is meant to point at something, is currently not pointing at anything, not a variable. So then when we try and do asterisk num pointer equals to number, we can't because there's no, that line says, hey, follow number pointer to where it's pointing to and change the value of the variable that it's pointing at. So under which case this line will work. So this scenario when they're both uninitialized, it won't work. But under which scenario it will work is, let's say if we had another variable called number 2 or something, right? And this number pointer was initialized to point at it, right? Then this particular line will work because then we're saying, hey, let's follow number pointer to where it's pointing to and update this value to whatever's in here. Does that make sense? This time we've got some storage space in the memory that we can actually store data, as opposed to if the pointer is uninitialized, then there's nowhere to store a value that it's trying to assign. Does that make sense? Maybe? Okay. I'm confusing myself now. But it is a bit confusing, so it might take some time. Woo. All right, so what's the point? We got a few questions before about what's the point. And I briefly mentioned it. So the TLDR is we can't return multiple values from a function, and that's not very nice in some places. And we can't return arrays. You may have discovered that. So some tasks where we are performing, where we're trying to perform things like swapping two variables and values and variables around in a function will cause issues if we don't have pointers. And I'm going to demonstrate that. Let me. Which one? Yes, we have another question.
but like where you say when your pointer isn't a specific memory address, your while loop is not gonna run. Can you do something like that?
Good question. That question might be better for after, because I think it might need a more detailed explanation there to be more specific. You can try and think about how you might do it, and then you can come to me after, and then we can figure that out. So yes. Shh. So I've got this code pointer in function.c. You should be able to access it in the directory as well. Currently it's got two functions. I've commented one of them out because I want to use a simpler one example to demonstrate what's happening first, and then we'll go to the more classic example, swap. I really want to talk about swap because it's so classic when we're talking about pointers that we talk about swap. Anyways, so here's my code, right? You might have it open on your laptops maybe. And all it does is it calls so it prints out the value of num. I did not. It prints out the value of num. I have a typo. Num1, sorry. And then it calls the function square num with num1, and then we print out the value of num1 again. Right? Square num is here, and all that does is it squares the number given. My question is, okay, and a Malteser for the answer to this question. What is the output? What is the value of num here? If I try and compile and run this code. So I haven't done any pointers yet. Yeah. 49? Where did you get line 49 from? 7 times 7? Oh, I can't do math. Yeah, 7 times 7 is 49. Now that's what we think. That's what we think should happen. Can we get a Malteser off of there? Thank you. That's what we think should happen. But that's actually a trick answer, a trick question. It doesn't actually print out 49, which is what we would expect, right? Should print 49. But it doesn't. Why doesn't it print 49? I know you can't see the whole code, so I recommend getting it up on your own thing. But why is it not 49? Why is it 7? Yes. We're still referencing num1, so how do I change this code to fix it up? Sorry, what was that? Percentage d. So here you want me to do like this? I can't quite hear you, I'm so sorry. Want to move the function into the print command, is that what you mean? Okay, apologies, it's a bit hard to hear you. Let's give that a go. Could that give us a hint? I really like how you gave that a go. Yes, please. You might have to walk. Yes. You in the front, sorry. Can you talk a bit louder? I'm so sorry, I can't hear everyone. isn't a variable. Sorry, what's that? I think you might be getting close to the answer. So it's something to do with yes.
I think what he was saying was that the square num isn't a variable. Because you haven't returned your answer.
Okay, that's one way to solve it. We haven't returned an answer yet.
Still a void.
Well, what's the core problem here? Like, yes.
Passing by value.
Yes.
Yes, thank you. Tim, Malteser, thank you. So this is something really important to know. Why is it not 49? It's 7. It's 7 because we're doing something where we're passing in num1 and it's taking a copy of the value. Okay, so when we are using functions with integer variables or double variables or any kind of variables, let me go back to my original code, like this. When you pass it in, this num1 becomes n, but it doesn't actually become n. What I mean by that is when you get to the function, n is a copy of what is in num1 in the main function. Okay, n is a copy of what is in num1 in the main function. So we pass the value of num1 to square num. Okay, n is a totally separate variable that exists inside the square num function. So when we say, hey, make n equal to n times n, if I try and print out n in function, the value here, oh, n in function will have the value of 49. Okay, because we're actually referring to the value, the variable we changed. This n inside, like I said, this n inside this function is different from num1 in our main function. Okay, when we are passing in our integer variable, it creates a separate copy. So if I were to draw a diagram really quickly to show this, because I want to demonstrate why we want pointers. Okay, let me do it here. All right, so if I were to draw a diagram, we have num1. Oh, okay. Technical difficulties. Okay, that's num1, which has the value of 7. When we call square num, we're actually going into a totally different function, right? So when square num is called with the value, what happens is now in the function we have a variable called n that copies over the value of 7 from num1. Okay, so when we say n equals to n times n, all we're saying is n here is equal to 49, 7 times 7. So then when we print out n, yes, it's printing out this value, but when we are finishing off or returning from this function, this gets destroyed, everything related, all the variables related to this function gets destroyed, and when we come back to the main function, num1 never got changed, okay? It's a totally separate copy, okay? So the key here is when we're passing in a variable into a function, it's actually a copy, okay? So then to resolve this, okay, this is where functions come in handy. So one way to resolve it, I think one of us mentioned it before, is you can return, why not just return n, right? Return n and then make like num1 equal to the return value to update num1. Now, the other way to do it is we change everything to take pointers, okay? We change this function, so instead of taking an integer, it's going to take an integer pointer variable, okay? So this is the first line I changed. I'm going to mark every single line I changed. Change this line. If I change that line, I will also need to change this line, right? I need to make it so that it's pointer, so that the prototypes match up. Now, if I change these two lines, it means the code within here has to change, okay? Where, I'm going to delete this line now. Now we're not dealing with an int. We're dealing with an int pointer. Okay? What do we do here? Okay, so this is a question. So, before we get to that, let's see how we're passing it in. Currently, we're passing an integer into the function when we're calling it. But because now we're expecting something that a pointer can store, we need to change that to an address. Okay? So instead of int, we're going to pass in the address of where our num1 lives. So that our pointer variable here can point to num1 from the main function. So what I mean by that, if I draw it on diagram, is instead of having these two as separate variables, separate integer variables, now I have, again, I'm going to use purple for the main function. So I have num1, which is 7. And then when I call square num, okay, when I call square num, it's passing in the address of num1. So let's say if the address of num1 was 0x77 blah blah blah, then it's passing in 0x7 blah blah blah. And then our n variable inside our function is going to have that address because that's what's being passed in. And this is a pointer variable, aka this variable here I've got. So that's basically pointing at the variable in my main function. Is that making sense? Yes. Where have I initialized the pointer? So in this case, it's like any other variables that we use as parameters for the functions. We don't need to separately declare. Are you talking about declaring it or initializing it? Yeah, declaring. We don't need to separately declare it. It's here. It's in the arguments for the function itself.
How does it know to point to
The reason why it knows is because when we call the function, that's what we're giving it as the argument. Does that make sense? It might be confusing. It might take a few times, but all I did was change the pointer to point to num1 from the main function. Okay, so the orange is in the function, the variable in the function. The purple is the variable in the main function. Purple, main, orange, square num. So with this, okay, in mind, how do I update this code? Because currently this code's not going to work because the function itself is assuming that I get an integer. So I need to update this. Okay. Can someone help me out here? What do I need to change here? Yes. So what's the symbol on the keyboard? Yes. So every single one of them will now have an asterisk, okay? Because, let me just show you it works first. Oh, let me just also check it works first. Okay, there we go. There we go. It changes to 49. Because n now is a pointer, so technically I can name an n pointer if I wanted to. But I'm just going to keep it this way. So then I'm saying, on my diagram, I'm dereferencing n. Okay, when I put the asterisk in front, I'm saying follow n to where it's pointing at and try and change that value there. Okay, change the value at the variable it's pointing at. Does anyone want me to explain that again? Are we all okay? Okay, I got a few. We've got a. Do you want me to explain that again? Okay, let's explain that once more. Because it is really important we understand this, and then I'll move on. So the key takeaway here is the main function's variable is different from, the main function's num1 variable is separate from the n variable we have in here. And I've changed the n here in the square num function into an int pointer now. And because I've changed that, I've also updated to add an ampersand in my num1. So what's happening here, if I redraw the diagram, is firstly, I declare num1 on line 10 and assign it a value, 7. Then I print it out, so I ignore that. And then on this line, when we call square num, we're saying, hey, square num, I'm going to give you the address of num1, and let's say the address of num1 is, again, 0x77. So basically, we're calling square num with the address. Okay, that's what gets passed into the function. So then when we get to the function, n, since n in the argument, in the parameter, is a pointer, the n in the square num function will now store 0x77, right? Which means it actually leads us to the where the variable num1 exists from the main function inside the memory. And so because we've got this structure going on now where we have a pointer pointing at a variable, we can now use the notations that we covered before, where we can put the asterisk in front of our pointer to be like, hey, go to the thing that the pointer is pointing to. And in this case, the thing that our n pointer is pointing to is our variable that contains the 7 when we put the asterisk in front. So go to the variable that n is pointing to, make that equal to the current value that n is pointing to times the current value that n is pointing to. Okay? All right. I'm going to leave it at that. We can have a think about this one, and you can come up if you still have questions after the lecture about this one. So moving on to the next example. So this is why pointers are useful, because now you can change things without having to return values. Oh, we've got a question. Yes. Here for this function. So this is the beauty of this example, because we don't, where is it? Because we don't need to return anything now. Since we've indirectly, remember how we can indirectly change the value of variables with our pointers? And this is exactly what's happening here. We can indirectly use a pointer in our function to change the variable from our main function. We're directly going to the piece of memory of the variable from our main function, our num1. Yes? So in this particular case, so the question is, can we just use the return value? Why do we have to use this? In this particular case, yes, you can avoid using pointers. However, this leads to my second example. My second example, okay, which is this one, where now there's two things. I'm uncommenting my second function. Now there's two things happening. There's two things that we want to be changing, okay? So the second example here is a function where given two integers or given two values, we want to swap the content of the two values around, right? Now, as we learned from the first example, we cannot do that with integers, okay? We can't be like n1 equals to something, n2 equals to something. That's not going to change it in the original function that we're calling it. So what's going to need to happen, right, is I'm going to need to switch every single one of these to a pointer. Okay? And if I switch this function to take pointers to pointer variables, which point to integer variables from our main function, I can now pass in the address of our integer variables. Okay? And so if I do that and I focus on working with pointers in my function, then the code of this will look something like this. Actually, we need to talk about swapping logic. Okay, stepping away from this for a second. Just looking at the logic of how we swap two numbers. Where is it? Here. Okay. I have a question. This is not related to pointers, just in general, the logic. If I have two numbers, right? This is 2, this has 3 in it, this is num1, this is num2. How do I swap the values around? I want num2 to have 2 and num1 to have the value of 3. Yes. Shh. It's really hard to hear. Yes. Superduce it. How do I switch it though? Because if I make num1 equal to num2, I lose the value in num1, right? Because that's going to change to 3. So what do I do? Yes. Create a new variable? Yeah, exactly. So I need to create a third variable, and I'm going to call it temp. It's just the temporary variable I have. And I'm going to store one of the values in here first. So I'm going to make temp equal to num1 first. So now I can comfortably change the value of num1 to num2. This is like backing up the value in num1. And then I can then say, well, now that I've got num1 having the value of num2, I can change the num2 value to num1, the original value of num1, which is temp. Okay? So we've got some swapping going around. Now, if I were to do this logic in our code with pointers, because in this particular case, I'm passing in, okay, the address of num1 and num2. So the address of these two, this one's OS66, this one's OS87, let's say. And then again, I'll use orange for the other function, the swap function. When I'm referring to n1 and n2 in my function, n1 is going to be pointing at, or it's going to be storing the address of num1, okay? Which is this. It's going to point at that. n2 is going to store the address of num2 from my main function. Okay? So that means I can now do something like this. I'll do line by line with my, let me rub this bit out. So this is the current situation I have. So I'm going to create a temp variable. And I'm making temp equal to the value that n1 is pointing to. Okay? Which means, hey, make the temp variable store the value n1 is pointing to, which is pointing at the value inside num1, which is the value of 2. Then I'm going to say, now can we change the value of the variable n1 is pointing to the value in n2? So that will go, hey, follow n1 to where it's pointing to. Change the value in here to what is in n2, what n2 is pointing to, which is 3. So I change this to 3. And then now I can safely say, hey, now let's go and change n2, and I want it to equal to temp. Okay, so that line saying, hey, follow n2 to where it's pointing to, change that value to what is in temp, which is the value of 2. And then now we've successfully got two things swapped around. Okay, so there's two difficult points here. One is we're dealing with two pointers variables. The other difficult point is this swapping logic might be confusing if you've never seen it before. But yes. Any questions? A raised question?
Why can't we just all on the integers individually instead of like rotating them around insert?
Call up on the integers individually. What do you mean by?
You said when you call on multiple values in a function, that's when it's useful.
Yeah.
Instead of using words, why can't I just call specific integers rather than using pointers?
Oh, so the benefit of pointers here, right? The benefit of pointers here is not actually within this function. It's when we call it here, right, if we don't use pointers, the numbers won't be swapped around.
So I just write like n1 your num1 equals num1 equals num2, and then num1 will become num2.
So let me show you. So this is what works, right? What works? The numbers are swapped around. If I show you the way, like let's say we don't use pointers, right? So let me get rid of all the pointers. So I'm just getting rid of all the asterisks. Shh. I'm just getting rid of all the asterisks in this particular function I'm implementing and everything related to pointers. So all I'm doing is passing in the two integers, right? And swapping. The issue here is the numbers won't swap around. Okay? So this comes back to the previous demo about square num, where when we are passing in the integer variables, a copy of them is being made. So when we are changing n1 and n2 and stuff in the function, we're changing the n1 and n2 variables that only exist within that function. When we go back to the main function, we're still referring to num1 and num2, which are totally separate from the n1 and n2. Does that make sense? Like when we are passing in num1 and num2 in this function call, it's not we're giving the variable to the other function. It's actually we are copying over the value from these two variables into n1 and n2 in the function.
But what I'm saying is instead of using n and a pointer, why don't you just directly use num1 and num2? Won't that switch it around?
Like as in change this. So this is not going to, this will still be the same issue. It's not actually passing. I deliberately used the different name because they're actually different things. Even if you have the same variable name, they're different things. So if I try and run this is a really good question because it's a very common misconception. So I'm really glad you asked this. So it doesn't actually swap it. Can you see that? Is that what you meant?
Yeah, but shouldn't it be swapping it because it's the same thing?
It's not the same thing. Here's the thing. Let me draw it again. Oh, give me a second. It's not the same thing because when we call swap num, so we've got num1 and num2 in the main function, right? Now, num1 has the value of 7, num2 has the value of 8. Keep in mind, I use purple for things in the main function. So when I call swap num1, num2, what's happening is I'm passing in the values of 7 and 8 into the function, okay? When I call this function, it creates two separate variables within the function called num1 and num2 that has the exact same values as what's in the main function because that's what's being passed in, okay, those values. It copies it over, okay? And because it's a totally separate copy in the function, although it has the same name, it's in a different scope in a way. So it exists within the function. And the num1 and num2, so the num1 and num2 in the main function is different from the num1 and num2 in the swap function. So then when we're swapping and changing the values in here and changing this to 7 and this to 8, the other way around, it only changes the orange, well, I don't have it here. It only changes the orange bit, right? And the orange bit is the variables in this function. It's not the ones in the main function. The ones in the main functions are the things in purple. The ones in the main function are the things in purple. Okay? So I think the thing to keep in mind is when you're passing in variables, like integer, double characters, they're only passed in by value, where the value is copied over into the variable in the function. So even if you have num1 in the main function and num1 in the swap function, they're totally two different variables because a copy of the value is being made. And you're modifying the copy. You're not actually modifying the original variable in the main. And this is why we need pointer, So then we can directly go to the source, the actual address of the variable in the main function, to modify the value there. If you come up later, I can explain a bit more. So that's the idea here, and I'm actually almost done. Shh. Any other questions? Might be very confusing. I'm happy to answer questions after, individually. Okay, so I think we got, moving on from this for now, we got another question before about arrays and pointers and the relationship. Yes. Yes. You've asked some really good questions, which are really important to answer. So this is really good. So what am I saying? Yes. We've got some questions about arrays and pointers, and I want to show you something. So if we have a look at this code here, array addresses, this code is doing a thing where we're changing the array in the function, okay? We're squaring the values in the array. And what I'm trying to say here, oh, I've been using GCC. That's not good. I should use DCC. Okay, so all this code does is it's going to take an array and it's going to square the values in the array. And it doesn't return anything, but notice how it's different with arrays. Before with the square num one, I said we either had to return it or we had to use pointers. Otherwise, it's just modifying the copy. But with arrays, it's different. It actually works without returning anything and without using any pointers, right? We see no asterisk, we see no ampersands, we see nothing. Like, why is it modifying for arrays? And this is where we get into the technical term of decaying, where arrays actually decay into pointers. Okay? What I mean by that is, let me just comment this out. I can print out this, okay? This is going to give me the address of the beginning of the array, which is the same as doing something like this. Okay? You can see these two are the exact same addresses. All that's saying, remember that your arrays are a collection of variables. So it's just giving you the address of the first variable in your array, the first element in your array. So what I'm trying to say here is whenever you're referring to the name of the array, it's always going to give you the address of the 0th element. The first one, then it's going to give you the next address. So you can see this one's incremented by 4 because int are 4 bytes. So the first 4 bytes is for the first element and the second 4 bytes are for the second element and so on. That's just an extra little thing I wanted to show. So one final thing, I want to make sure I cover this because this leads onto linked list in after Flex Week. So I mentioned how I've demonstrated pointers with integer, but we can have doubles, we can have chars, all of it work in the same way. It's just what the variable is storing and how you declare them. And I've just put it on the slides. Now we can also have something called struct pointers, okay? So here, what I've got is a struct student. And currently, it's a struct student as it is. I can make this a pointer, okay? I can make this a pointer. And then what I will have to do now, okay, instead of a dot notation, is because now it's a pointer, I will need to make it point to some struct. Actually, let me do it the other way around. I'm going to leave this as a student, and I'm going to create a pointer to point to it. So I can create a struct student pointer and make that point to the address. What that means is now I can print the student name, the student ID, and the mark with a notation that looks like this. Okay? Let me just show you this. So the dot notation was when we were working with structs. Now we can work with struct pointers, and if you're referring to structs with pointers, which in this case, sorry, it's PTR, yes. Good pickup. Then if you're working with pointers and you're trying to access a struct that it's pointing at, you will use the arrow notation. So let me fix this bit, because I was going to cover this, but it's fine. So remember your string copy, when you're dealing with strings, it's not actually an equal sign. So the point I want to show is, this is going to print out all the information. I've used the arrow notation because I'm using the pointer. If I use the stew, then I'll use the dot notation, right? Now what this arrow notation is actually talking about is, let's say I'm doing PTR name, okay? What that means is it's actually the same as saying this. Dereference the pointer, so follow the pointer to where it's pointing to, which is the struct student, and access the name inside that struct. Okay, so all that's doing is I have a pointer called PTR, and it's pointing at a struct student. And then we're dereferencing PTR to access each element inside it. Okay, so whenever you're dealing with pointers and structs, you will use this arrow notation. That's the one more thing that I wanted to mention. Otherwise, we don't have time for Kahoot, because it's better if we understand this or cover this more than the Kahoot itself. Otherwise, it's Flex Week next week. Can everyone please, if you have time later on or now, give me some feedback by sending the QR code. This is my first time teaching pointers, so I got quite nervous. It would be really helpful if you can give me some feedback to help me improve. And if you have any questions, you can come up. Remember, Flex Week is next week, so no classes. Thank you, everyone.
I got a question.